Today, students, in this video we are going to discuss how we can determine if lines are parallel, perpendicular, or neither, and then we're going to find equations of parallel and perpendicular lines. And then we'll discuss geometric applications of parallel and perpendicular lines. So if we recall, two lines are parallel if and only if they have the same slope. So here in this image of these two lines, although we can't calculate the slope, these two lines will never intersect because their rise and their run is the same, which what makes them parallel. And for perpendicular lines, as long as they are non-vertical, two lines are perpendicular if the product of their slopes is -1. So if I have one line and this slope is L over B, and I have another line its slope is -B over A, if I multiply those together, I have a product of -1, and that makes them perpendicular. And I know previously in probably Algebra 1 or Algebra 2, your teacher might have said these lines were perpendicular because their slopes have opposite values and they were reciprocals of each other. So we can also use that as well. This one's positive, this one's negative, so that means they have an opposite sign, and then reciprocal, so A over B, its reciprocal is B over A. So we could use that as well to determine if two lines are perpendicular. Now for our first example, so I'm going to do this one and then you're going to do this one, I want to determine whether or not these two lines are parallel, so they have the same slope, perpendicular, when I calculate the slopes they're opposite reciprocals, or they meet neither of those conditions. So to find the slope, since these equations are in standard form, I'm going to do both. I'm going to solve for y, both of them, and then I'm going to use a shortcut I showed yesterday in the previous video. So for this particular equation, if I isolate the y variable, get it by itself, this is the equation I get. So add 8x to both sides, since that was -8x, and then I'm going to divide everything by -2. And so this is my equation of slope-intercept form, and my slope is -4. The shortcut method is to look at the value of A, which is -8, or look at the value of B, which is -2. And if I divide those, so it's the opposite of A, or -A divided by B. Since A was -8, I take the opposite of that, or the negative of that, and divide it by -2, and I get -4. So here we see we get the same slope whether I solve it by hand or I use the shortcut that we talked about previously. And now when I find the slope of this equation, which is in standard form, I'm going to do the same method. I'm going to solve it for y, and I'm going to use a shortcut, and I'm going to compare those slopes to see if they're going to tell me the lines are parallel, perpendicular, or neither. So when I solve it for y, subtract 3x from both sides, and then divide everything by -12, I get y equals 1/4 x plus 1/2. I'm only really concerned with the slope, so I don't really need the y-intercept right now, but my slope is 1/4, and using the shortcut, I get the same. So A and B, the opposite of A, so the opposite of 3 is -3, divide that by -12, I get 1/4. And when I compare those two numbers, the first slope was -4, the second slope was 1/4. Clearly they're not the same. They are opposite in opposite signs, so one's negative, one's positive, and they are reciprocals of each other. So we would say that these two lines are perpendicular, or we can use the theorem, and I can multiply those two numbers together, I get -1. So either way, we are able to determine that those two lines are perpendicular. So they intersect at a 90-degree angle. And I want you to try the same thing with the tube down here. Find the slopes of each line. You can either solve it by hand like I did, or you can use a shortcut like I did as well, and determine if they're parallel, perpendicular, or neither. So you should have gotten that they were neither, because the slope of the first one is 6/5 and the slope of the second one is 4/5, and those are definitely not equal, nor are they opposite reciprocals, nor if you multiply them together you get -1. So they don't meet the condition for parallel, they don't meet the condition for perpendicular, so we would say that the lines are neither parallel nor perpendicular. Now for the second part of our learning target, we would like to write an equation in slope-intercept form, in standard form, or in point-slope form, in slope-intercept form, and then standard form that's parallel to an equation and passes through a certain point. So in order to do that, we know that parallel lines have the same slope. That means that if I want to write these three equations so that they are parallel to this equation, which is in point-slope form, I'm going to use the slope of 2 that they give me. But I'm going to use this point as well. So in my point-slope form, I'm using the slope of 2, and I'm using this point to set this up. And so this is how it will look if I set it up. Y minus -3, that's my y value. 2 is my slope, and x minus -5. I simplify this to keep it in point-slope form, and this is my point-slope form answer. And I'm going to take this answer and use it to write the equation in the slope-intercept form. So now I take that same equation right over here, and to get it in slope-intercept form, I need to make it look like this, which means to bring the 3 over and to get rid of the parentheses. So we're going to distribute and then bring that 3 value over. And so this is my slope-intercept form equation. And I want to take that equation, I want to write it in the standard form. To get in the standard form, I want to have the x and the y's together. So I got to take this 2x term and bring it over. So use my inverse operation, subtract 2x from both sides, and this is what I get. But remember earlier in the video from 2.3 over lines, I did say that this value should be positive. So I would multiply everything by -1, and this would be my equation in standard form. Your homework may accept this as the answer, but true standard form, the value for A is positive. But these three equations, if I were to graph them in the calculator along with this one, well, these three would be the same, but they all would be parallel to this one because each of them have the same slope of 2. So I want you to try this one. I want you to find the slope of this line so that you can write the equation in point-slope form, slope-intercept form, and standard form. That goes through this point. And remember, for parallel, it has to be the same slope. So you can definitely use the opposite of A divided by B to find your slope. So if you had trouble finding your slope, it's 2/3 because I took the opposite of A, which is -4, over -6. That gives me 2/3 in this point. So now you can go ahead and set that up, and this is what you should get for your answer. Each of these values, or each of these equations, are parallel to this line and passes through this point. And in fact, I can take my final equation in standard form and take the x value, replace it here, so 2 times 2 is 4. Take my y value, replace it here, -3 times -5 is 15, and so that gives me 19. So I know if this is true for this last equation, then the other two must be correct as well, because this equation came from this one, and this blue one came from the black one. And so that's how we can check to make sure that our equations are correct and accurate. Now I want to write an equation that's perpendicular. So for it to be perpendicular, unlike parallel, I have to make sure that I use a slope that's the opposite sign of the slope of this line, and also its reciprocal. So I'm going to use the shortcut, which is the opposite of A divided by B, to find my slope. And that will give me a slope of 5/2 for this line. And since that's the slope, I want to make sure that I use the slope that has an opposite reciprocal in my equation. So the slope that we would like to use would be -2/5, since the slope of this line is 5/2. A line that's perpendicular will have a slope of -2/5. So I'm going to use this slope and this point in point-slope form. And here I see that if I set it up, y minus -3 equals -2/5 times x minus 4. Simplify that, that turns to a plus sign. So this is my equation in point-slope form. I'm going to take that same equation, bring it over here, and I'm going to solve it for y for slope-intercept form. So once I distribute and solve this for y, bring in my 3 over, so subtracting 3. So 8/5 minus 3 is the same as saying 8/5 minus 15/5. And that's where I get the -7/5. You can evaluate that in your calculator. But this is my equation in slope-intercept form because it's in the form of y equals mx plus b. And I take that equation, bring it over here so I can change it into standard form. And to change that into standard form, I'm going to move the x term over with the y. So adding 2/5 x to both sides because that was negative to before. and I want to clear my denominator of fractions, so the LCD is 5, multiply the whole entire equation by 5, and this is the answer I end up with, 2x plus 5y equals -7. So if I graph any one of these in the calculator along with this one, then they should be perpendicular, so they cross at a 90-degree angle, and they each contain this point. And I can check that by taking this point, replacing it with x and y, and seeing that it equals -7. So I'm going to have you try this one to see if you can write an equation for a perpendicular line to this equation. So the slope is 5, which means you're going to change that, and it passes through this point. So for your part, you should have used the slope of -1/5, which is a perpendicular slope to 5. And this is how your setup should look. So starting with point slope form, I use my slope of -1/5. I have my point of -2 and -4, replace those in the right spot respectively, and then we simplify it. And so this is my point slope form equation that's perpendicular to this line. And then I take that value, or I take this equation, and I transform it or change it into slope intercept form by distributing the fraction, -1/5, and then bringing over or subtracting 4 from both sides. So -2/5 minus 4 is the same as saying -2/5 minus 20/5, which is where I get -22/5. And now this is my slope intercept form equation, and I take that same equation, bring it over here, and change it into standard form. So I need to bring the x with the y. I'm going to add 1/5 x to both sides, and then this is somewhat in standard form, but I want to make sure I get rid of my denominators. This value is already positive, so I don't have to worry about that. So to clear my denominators, I'm going to find the LCD, which happens to be 5. So multiply each term by 5, and I'm left with x plus 5y equals -22. And if I replace the x with -2, and if I replace the y with -4, I get -22 as my value. So this equation does work for this ordered pair, which means the other one should work as well. And this equation is perpendicular to this line because this equation has a slope that's -1/5. So this is our last section for chapter 2, and then we should be reviewing for our test that's going to be coming up here within the next couple of days.